Okay, we're up to lesson 7 in this little series on chaos, fractals, and dynamics, computer experiments in mathematics. That's the title of the book I'm using to get most of this information. It's been written by Dr. Robert L. Devaney. And you will remember, I hope you remember that over the last few lessons, what we've done is we've looked at the iteration on y equals x squared plus c. F of x equals x squared plus c over the real values of c using a seed of 0, and we let c vary from 0.25 to -2, and we saw all sorts of interesting behavior. And that behavior involves sometimes converging towards one number, sometimes converging towards oscillating between 2 numbers, 3 numbers, any number of numbers. And what we want to do is to get one picture of all this behavior. And to do that, we're going to start out by taking a few points. So I'm going to look at c equals -0.8, -1.3, and etc. These numbers in the table, which I've checked in advance. I know how many cycles each one has, and I just want to confirm that. So we're going to take c, and we're going to set it at -0.8. We can see, in fact, there are 2 cycles, and there we go, the 2 cycles that it settles down to fairly quickly. -1.3, 2 cycles, and then it switches over. You remember, it bifurcates, which means the period doubles. So now when we hit -1.3, actually even before that, but -1.3 is the number I just chose, sort of at random, you can see we have 4 different values here on our histogram that it's settled down to. So that's a 4 cycle. -1.39 is an 8 cycle. Then we go through all sorts of different things, and there's a chaotic region there, and we'll get to -1.475. Interestingly enough, it gets back down to a 6 cycle, and then -1.575 is a 7 cycle, and so on. So we can find all those simply by going through here, and I've done that in advance. You'll notice in between some of these, like right here, -1.76, we have a 3 cycle, but right before that and right after, we're into chaos again. Okay, so we're going to take this table and we're going to put it into a slightly different program. Okay, what I have here with this graph, I have values of c down here, and I'm going to iterate, and I'm going to graph the iteration values versus c. And right now I have c set at -0.8, so I expect to see a 2 cycle eventually. And I'm starting my n at 20, so I'm skipping graphing the first few so we don't get the numbers that appear before we get close to the 2 cycle. So let's vary that n, make it grow from 20, and we can see it's alternating back and forth. And what I want to do is save that picture, so I'm going to put the trace on, and now those 2 points are fixed. We can see them if we need to come back to them, and we will. Now I'm going to go all the way to -1.3. And -1.3 should give me a 4 cycle, so I'm going to trace those. And you see it's going between those 4, and even though I'm changing the value of n, you aren't seeing any new numbers coming up because it's hitting those same spaces over and over again. So it's alternating among those 4 iteration values. Now we're going to go to -1.39. And at -1.39, you can see it's jumping all over the place because if we trace it, we'll see we've got an 8 cycle. 1, 2, 3, 4, 5, 6, and those 2 very close to each other, 7 and 8. What I'm going to do is to continue to go across here, -1.475, all these other numbers, and I'm going to get those iterations graphed. There we go. Now what I'd like to do is come on over here to one of the 1 cycles, negative point. See what I'm doing is I'm changing the value of c, and I'm seeing all of these 1 cycles. Now this one right here is actually a 2 cycle, but I kept the value of n at 54. So what I'm going to do now, I'm going to let c vary and see what happens, and I'm also going to let n vary. So what it's doing we're moving to the right, and it's just graphing different values of the, so it might graph the 50th iteration one time, the 100th iteration another time. So when it comes back over here, we'll see that as we gradually get all of the iterations, or a lot of them, over various values of C, that we get one picture that shows us the entire orbit or bifurcation diagram. Let me just go through that and explain that. Okay, right here at negative 1.3, see that right there? We have a 4 cycle. 1, 2, 3, 4. And this whole region here we can see is 4 cycles from about negative 1.39 to maybe negative 1.25. Well, it is negative 1.25. Remember, that's the bifurcation point. So we can see the bifurcation. Here was the first bifurcation at negative 0.75. All along here was an eventual 1 cycle. Then we have eventual 2 cycles, 4 cycles. And it splits, and we have all sorts of possibilities here. The region in here is chaotic. And so we really can't tell how many cycles there are, but we can see, like at negative 1.775, there's kind of an open region here where you have 5 cycles. Well, this isn't a very good picture because I don't have a whole lot of points, so what I'm going to do is show you a more detailed picture of this. And here it is. There's our orbit diagram, or our bifurcation diagram. 1 cycle, 2 cycle, bifurcation point right there. 4 cycle with a bifurcation point there. A lot of chaotic regions, but within these chaotic regions you can see these little open areas where just for a short region we have a very few cycles. Okay, you might remember in this region here, this looks like this was a 3 cycle. And so that's the orbit diagram, or the bifurcation diagram, for y equals x squared plus 6. It shows all of the behavior of all of the important behavior of this iteration, and it enables you to see how the bifurcation, where the bifurcations occur and where the chaotic regions are. Just a general overall view of it. Now this is